In this video, we will solve a cost minimization problem. The question is, a producer decides to minimize the cost of production. That is, cost function is being given as C is equal to 8L plus 4K, subject to the constraint Q is equal to 2L raised power 1 upon 3 times K raised power 2 upon 3, where symbols have usual meanings. Find out the equilibrium combination of L and K in order to minimize the cost of production when Q is equal to 64. Okay, so this is actually the cost minimization problem. So what we are supposed to do here, we want to minimize the cost, that is minimize the cost. C is equal to we have 8 times L plus 4 times K. Now what does this mean? 8 denotes the price of labor, L denotes labor, K denotes capital. Okay, so 8 denotes the price of labor, 4 denotes the price of capital. We want to minimize the cost subject to the production constraint. We are facing this constraint, that is 2 times L raised power 1 upon 3 times K raised power 2 upon 3 should be equal to Q, and we are being told when we produce 64 units, so in place of Q we write 64. Okay, so it is actually a production function in two inputs, that is labor and capital. We want to minimize the cost with the given production constraint. Okay, let me draw a simple graph here to make sense what we are trying to do. So let us draw a simple graph. Let us say we have labor on the horizontal axis, capital on the vertical axis. Okay, we are being given the production ISO count here. Okay, we are being given production ISO count. We want to minimize, and if I draw the production ISO count here like this is our ISO count. We want to produce on this production ISO count with minimum cost, and minimum cost will occur at a point, and let's draw the ISO cost function here. Will be like this. Okay, there can be another like this. This is also our ISO cost line, but we want to minimize the cost, and for equilibrium combination of labor and capital that minimize the cost of production will be at a point where the ISO cost line is tangent to the ISO count line. So at this point, okay, and let me write it here. For equilibrium, what will happen? We should have, that is the marginal rate of technical substitution between labor and capital should be equal to the input prices ratio, that is price of labor upon price of capital. Okay, so at equilibrium what will happen? The marginal rate of technical substitution between labor and capital should be equal to price of labor upon price of capital. Now what is MRPS? It is in fact the slope of that is it is the slope of this this ISO count, which is being denoted by black color, so which is equal to the ratio of the marginal product of labor upon marginal product of capital, and it should be equal to the input prices ratio, that is price of labor upon price of capital here. Now we need to see what is meant by MPL. Marginal product of labor means the change in the production due to the change in the input, which is L here. Okay, the change in the total output due to the change in the input labor, that is marginal product of labor. Similarly, marginal product of capital means the change in the total production due to the change in the units of capital employed. Okay, so and it should be equal to price of labor upon price of capital. Remember here, LHS denotes the slope of this black line, that is the ISO count, and RHS denotes the slope of the ISO cost line. Now we need to find out here rather we need to calculate the this derivative, the partial derivative of production function with respect to labor. Okay, so we have this production function, given production function. If I write it here, Q is equal to 2 L raised power 1 upon 3 times K raised power 2 upon 3. We need to partially differentiate it with respect to L first. Okay, so dq upon dl means the partial derivative of this function with respect to L. Using power function rule, 1 upon 3 becomes coefficient. Then we have 2 and exponent is subtracted by 1. So 1 upon 3 minus 1 is minus 2 upon 3. K raised power 2 upon 3 will remain same because we are taking the partials with respect to L. Similarly, dq upon dk means the partial derivative of this production function with respect to K. Again, the exponent of K becomes coefficient, so we have 2 upon 3 into this 2. Then we have L raised power 1 upon 3 will remain same, and K raised power exponent is subtracted by 1, so 2 minus 3 is minus 1 upon 3, and it should be equal to input price ratio. Price of labor is 8, price of capital is 4, so we have 8 upon 4 here. Solving further, there will be some cancellation. 2 and 2 gets cancelled. When we solve this, okay, or let me write it here. Can I write 1 upon 3? Transposing, it becomes 3 upon 2. Then we have, and let me write first K raised power 1 upon 2, K raised power rather 2 upon 3. Then let me write L raised power 1 upon 3. Now transpose this to denominator, and this to numerator. So we have here K raised power plus 1 upon 3, and transposing this to denominator, it becomes L raised power plus 2 upon 3. Okay, when we change the terms from numerator to denominator, exponent sign changes. So 8 upon 4 is equal to 2. Doing some basics, and let me do the basics here first. 3 and 3 gets cancelled. Bases are same, we can add up the exponents. So we have K, or let me write it here. So we have K raised power 2 upon 3 plus 1 upon 3. Simple, bases are same, we can add up the exponents. Similarly here, bases are same, we can add up the exponents. So we get 1 upon 3 plus 2 upon 3 should be equal to 2. So 2 upon 3 plus 1 upon 3, it sums out to be 1, so which implies K upon L should be equal to 2. But I am missing something here. I have 1 upon 2 here also, 1 upon 2, which gives us K will be equal to, transposing this, it becomes 2L. Now plug this value of K is equal to 2L into the production constant. Okay, in this equation, so we have twice L raised power 1 upon 3. In place of K, can we write 2L raised power 2 upon 3 should be equal to 64. Solving further, or let me write it here. So we have 2 L raised power 1 upon 3. Then expanding this, we have 2 raised power okay, so I have 2 here. K should be equal to, so we have 2 into 2, I am doing some mistake, 2 to the 4L, my mistake, so it is here 4L. So here we have 4L. Okay, so we have twice L raised power 1 upon 3. Here we have 4 raised power 2 upon 3 times L raised power 2 upon 3 should be equal to 64. Let me see if I can do some. So we have 2 L raised power 1 upon 3. Can I write I am doing a mistake somewhere, and I am not sure where I am you know, 8 upon 4, rather price of labor was 4. I am really sorry, the question, if I solve this question like this, okay, let us say this is 8 upon 4, it is 2. So having said that, when we solve this, and can we solve this here for L? We cannot solve this L, so I have made a mistake in calculating this stuff. It is here in fact equal to 2, so our production cost is here 2k. Okay, so let me see where I have done the mistake. So it is here 4. Okay, or let me rub the other step also here. The problem was in the question. I could have solved with 4, but it would be you know, a complex situation in calculating the cubes here. So in fact the question was 8L plus 2k. Okay, so we want to, here it is also 2. Okay, so k will be equal to, when we solve this, and let me rub this out for the sake of simplicity. I know I have done this cover, I don't know, I was not in my mind. So here we get 1 upon 3 times 2 upon 3 k upon L is equal to 4. Okay, so we are done with this. 1 upon 3 upon 3 upon 2, rather big 3 upon 2. Okay, 1 upon 3 transposing 3 upon 3, 3 gets cancelled, we are left with, so k upon L will be equal to 4 to the 8, rather k upon L is equal to 8, which implies k is equal to 8L. Okay, now plug this into here, so we get twice r raised power 1 upon 3. In place of k, can I write 8L? I can write 8L raised power 2 upon 3 should be equal to 64. Now I can see the question is correct. So we have 2 r raised power 1 upon 3. So in place of 8, can I write 2 cube raised power 2 upon 3. Expanding this, we get r raised power 2 upon 3 is equal to 64. So 3 and 3 gets cancelled. That's why the cancellation was not possible earlier. So we get 2 r raised power 1 upon 3, r raised power 2 upon 3. 1 upon 3 plus 2 upon 3 is 1. So we get here L, and we get 2 to the 4 should be equal to 64, which implies 4 to the 8L is equal to 64. Dividing both sides by 8, L will be equal to 8. Okay, so L will be equal to 8. We need to imply 8 units of labor. To find out the units of capital, simply plug L is equal to 8 in this equation. Okay, so here, so k will be equal to 8 into the value of 8 is L is 8, which gets out to be 64. Okay, so we need to apply 64 units of capital and 8 units of labor to minimize the cost. And we can also find out the minimum cost, that is cost will be equal to 8 times the value of L, which is 8, plus 2 times k, the units of k is 64. So this becomes, look at big, 64. So it is equal to 8 8 are 64 plus 4 8. So it comes out to be C will be equal to 8 now. So we get 192 as the cost. Okay, so it was simple, but I was confused. Here I have done the mistake because cost function was 8L plus 2k, not as 8L plus 4k. I hope I make myself clear in this video. Thank you.